right. Hello, everyone, and goodbye, useState. First of all, who am I? It doesn't matter because we have so much to talk about right now. I only have half an hour, so I'm really just going to get started with this. If there's one thing that you should know about me, it's that a couple years ago I gave a talk about useEffect, and the talk was actually titled Goodbye useEffect, where I talked about the defects and how really it's a foot gun. And the first couple times that I gave that talk, people just came out with pitchforks. They were like, oh, you call yourself a senior React developer, you don't even know useEffect, etc. Why are you saying useEffect is so bad? And then the React team actually wrote documentation on how you might not need an effect. This was great because my future talks on Goodbye useEffect were basically just reading the documentation, which you all should do anyway. So we are here to talk about useStates. And now, I'm not going to say like you should never use states or anything like that, but I just think we're using it a little bit too much. Now, I get it. In the React survey that came out, useState had like the highest retention, the highest happiness. Like it's the most used thing in the React ecosystem. And I mean, there's other surprising things over here. Like, who still uses Axios? Fetch is right there. Like, stop, okay? It's 2025. All right, so, but in order to level set with you, what we're going to be talking about is better patterns now that React 19 is out, and patterns that we could even revisit now that we, can organize our React applications a little bit better. So first, I want to talk about just some of the weird stuff about useState, like closures, batching, etc. I mean, this is something that a lot of beginner and even more experienced React developers fall into, where we just depend on like, oh, this count is going to be updated. So when you get 60 plus 8 plus 1, obviously you're going to get, well, 1. Because it's really taking the last set count and it's using that. If you thought it's a different number, don't be dirty. It's not the number. But you're going to want to use a setter instead. So with a setter, you avoid the problem of closures, and this is all going to be batched, and it's going to be calculated one at a time so that you get your final count of 42. So that's just one of the weird things that a lot of you probably have gotten used to already with useStates. One that I actually encountered because I like using these obscure but native JavaScript things like maps and sets is that useState doesn't really work with maps or sets. And these are the most terribly named variables. We have set, stat, set, and then you could set, and then set, add, set, and then this button you could click set. But this is not actually going to work. And why is it not going to work? Can anyone tell me? Because it is the same object identity, right? So React's going to detect that nothing really changed. So you could sort of trick it, I guess, by, well, what I'm doing is I'm wrapping it in an array, and then basically we're just, I'm hearing a lot of moaning, and trust me, this is a disgusting pattern. But if you do need to use set, then you could just do that. And again, some of you will be like, why would I ever do that? The truth is that working with maps and sets in React, just good luck, figure it out. I don't know. But yeah, in general, use state setters because they're going to give you the previous state, and it's going to be a more reliable way of updating your state. And beware of closures and object identity, because it's something that trips a lot of React developers up when you are returning the same or a different object, and you might be causing multiple re-renders. And speaking of re-renders, here's another weird thing about useState, is that let's say that you have a value in useState, and it is being read by multiple components. So we might want to just lift this state up and use just prop drilling to bring that value into those components. But the problem is that this is going to cause a lot of re-rendering. So whenever you change the value in useState, it will re-render everything that's in that component and under it, and that can be really undesirable. But sometimes it's unavoidable. However, in situations like this, let's say that we only want to track the number of times the button has been clicked. So we have handled click over here, and then we're setting the click count, and then we're tracking however many times the button was clicked. You might think, yeah, this is a really good use case for states because it's literally states that we have to keep track of. But the thing is that this will cause a re-render, and nothing is actually re-rendering in the component. So instead, you could just use a ref. And so this is where refs are really useful in place of useStates, is when you don't actually need that state value to re-render anything in your component. So in general, you really, as much as you can, try to keep useState as local as possible. Don't give in to the temptation to lift it up and just have it be shared between multiple components. That's what things like context and other things we'll talk about later are for. And you can use ref for internal states that should not cause any re-rendering. So basically, states that doesn't really have to do with the UI. Another thing, and this is where we're really getting into how we could remove our usage of useState, this really cool concept of using URL as states. So take this, for instance. We have a sort component, and we want to set the sorting on some table to ascending or descending. useState is fine here, but guess what? If you change it to descending, and then the user reloads the page, guess what? It's going to go back to whatever the original sort was. I put it as null, but that might be ascending or descending. You don't know. And so what can we do? We can actually use the URL and search parameters in the URL. I'm not going to go too deep into this because there's a following talk that will. But for example, you could use next, and next has a hook called use search params, and that way you could grab the sort, but updating those search params is a bit awkward because you have to create a query string, and then you have to basically do router.push, and then set the query string to whatever that value is. Really, really weird. This is something where I think Remix really shines because this is all you need to do. You just, it's basically like useStates, but for search params. In a way, there's still a little bit of awkwardness here, but it actually works a lot better than Next.js. But there's also Nux. And so Nux, this is what the following talk is going to be about. This is basically useState, but for your search parameters. Why do you want to do this? Why do you want to put state in your URL instead of in your component? There's a lot of advantages. Again, we're going to hear about that from Francois. Here he's the best, so he will talk to you about that. And I tried it. It works really, really well. So in general, consider using search parameters in the URL for URL persisted states, because that can be read in multiple components. It's like this global beyond the app context, and you could also persist that state. And Francois is going to talk about much more of those benefits coming up next. All right, another one of my favorite topics, fetching data. We've all written this a million times. We have is loading, set is loading, error, set error, etc. In fact, if you were to search your code bases, just search for set loading. You're going to find like a million of these. Why? Because if you're an experienced React developer, these are baked into our muscle memory. Like we know, oh, I have to fetch some data. Okay, is loading, error, data, use effect, set is loading true. Like all of this is muscle memory. And in fact, if you're a more experienced React developer, you'll remember to do cancellation, which I forgot to do here. Like let is canceled equals false, and then you set is canceled equals true whenever the effect has to rerun. It's just really, really confusing. But guess what? We have server components. This is the only logo I could find of it, but RSCs, very, very, very useful. Yeah, I swear this is like one of the first logos I saw. But basically, we could just fetch right in the component. And we're going to hear a talk from Aurora in this same block, more about just server components and server-side fetching. But it really, really eliminates the usage of, or the need for useStates, because we could just fetch directly in the component and then use that data directly. And then you could also use suspense if you really want to control the loading states. I actually didn't have time to write a code example for this, but hopefully Aurora will show you that. Otherwise, you could just read the docs. Suspense is really useful for that too. There's another very cool hook called called use transition. And so with use transition, you can actually start a promise inside of it, and that way you don't have to have that set loading, is loading Boolean state, because that is handled in the hook itself. Now, the purpose of use transition is a little bit more nuanced, as the React team likes to call it, because it's more about like deprioritizing state updates and marking something as not a priority so that the rest of your UI could remain responsive or something like that. I'm not smart enough to understand that, so I just use it for handling promise dates and things like that. But it works really well for that purpose. Or you could just use React query or Tanstack query, because honestly, it's going to handle fetching data better than you. And even if you manage to figure out like, oh yeah, these are all the states I need, and this is the cache I need to set up and everything like that, they've already figured this out. Don't reinvent the wheel. They've made a very, very, very good wheel. And people do get upset at me when I talk about that. But yeah, there's a reason that Tanstack query exists. So fetching data, we can eliminate a lot of useState from that. We could use server components whenever it applies. We could use suspense for controlling loading states, and hooks like use transition for local pending states, and other things like deprioritizing UI updates. And honestly, if we really want to eliminate boilerplate and eliminate all of those use states for fetching data, query libraries have already solved this, such as Tanstack query. All right, so now forms. This is another big one where we just have use states all over the place. Here's an example form, and this is one of the smaller ones. They do get pretty big. So we have a few variables for first name. I have a variable called variable. I don't know why I have that. And bio. And so this is something that we all learn when we're first learning React. We make a simple form. We have a few fields. And then in our inputs, we just handle updating those with onChange. This is very basic React 101 stuff. However, for simple forms, we actually might not really need that, because the browser has a built-in API called form data. And so when you submit a form, you already get that form data. So the best way to think about this is that we're actually redundantly copying states from the inputs into our React components, but the browser is already holding onto that state for us. When you type in an input, that input has an input.value. And so that state's already there. It's like the browser's own built-in useState. So why are we duplicating it? There might be some good reasons where you might want to display the typed value somewhere else, although I've really only seen that in toy examples and not too often in places where it actually matters. Like usually it's just whatever's on the form is there. We're not needing to duplicate data anywhere else, and we just need to submit all of that data all at once somewhere. And so this is a great use case for form data, which is native HTML5. And if you are worried about type safety, then you could use a client-side type library or a runtime type validation library like Zod. So we have this user shape over here, or user schema, and then we could parse the form data, where the form data gives us objects from entries, because you could have many inputs with the same name. So yeah, you just call object.fromEntries, you get a nice object, and then you can ensure that it fits that user schema. Now, I mention this because I know that you all are not going to just rewrite your forms and be like, let's get rid of all this useState and let's use form data. But it is important to mention this because the way that frameworks such as Remix and Next.js, and I'm sure even Tanstack Start, which was just recently released, they work with the same concept in mind. So with Remix, you have the form components, and so basically there's no useState here at all. You just have method post, action some action, just like we're doing PHP again, and then all of that data gets sent up to the action as form data that we could use directly. And then for Big Triangle Company, we have something similar where we have, sorry, I forgot that I added that. We have useActionStates, and with useActionStates, you could actually pass in that form action. So for example, create user. So we have useActionState with create user. And then you already get a pending variable, so it's actually pretty useful where you don't really have to manage those loading states. And yeah, so again, there's no useState in sight here. This is just going to go directly to that action that you've defined. We have the form data over here. Again, you could use za to validate that shape and make sure that it is exactly the same shape as you expect. And then you could use it directly in that action. So Next.js uses form data, Remix uses form data, or you could use form data directly. But I know some of you will say like, hey, I have a form with complex validation requirements and it needs to be validated on blur, but only after a debounce or something like that. And what you're going to end up doing is reinventing one of these libraries. Don't do that. Again, these libraries exist for a reason. And so if you really want to control complex form logic, I highly recommend either React Hook Form, which is one of the most popular ones, or TanStack Form, which is a really solid form library, and it was also recently released, I believe. So in general, with forms, use native form data if you want to. And also, runtime type checking libraries like Zod are extremely useful. Take advantage of the framework features for your forms, or maybe even use form libraries for more advanced forms. All right, so now over using state. You might be thinking, like, I don't really have a problem with useState. It's easy. It's a very simple API. But eventually, you know, it never starts like, it never ends like this. It starts like this, but you eventually go from useStates to use8. And then things get worse and worse and worse and worse. You know what we call this? This is vibe state management. And this is what Cursor is going to output when you just let it run wild. So yeah, what can we do about this? And this is an exaggeration, but this is how, let's be honest, a lot of our code looks, especially with bigger and bigger forms. So one technique that we could do, not getting rid of all the useState, but instead just grouping data together, where if we have related pieces of states, then honestly, they should really stay together. Now, this does require a little bit more work in order to, for example, update each individual field. So I have a custom function here called handleChange that helps me do this. But honestly, having a single useState makes it much more manageable and easier to reason about, especially when you're working with a bigger team. If you really don't want to like just manage all of those, or sorry, create those custom functions for managing things, use something like Immer, because Immer has a very useful produce function where you could actually manipulate a draft, and that's it's not really mutating the actual data. Instead, Immer is taking that as patches, and it's saying, like, these are the operations I need to do immutably to the original object, and then it returns that object without actually mutating it. So very, very simple one-liner. Another pattern I've seen, too, is when we're doing things like steps. So for example, we have an address step, payment step, confirmation step, complete step, and we could really reduce these into just a single string enum like this. So now all we have is address, and then when we go to the next steps, we could just set that directly. So that's another important concept I want you to keep in mind, is using string enums to just eliminate all of those Boolean state values that we have. Group related state together, use Immer for easily managing complex state updates. String enums really help you get rid of all those Boolean values, and think before vibe coding. Now, let's go a little bit further with enums, because Again, this is code we have seen all the time. We have data, loading, error. And the problem with this, though, is that how can you guarantee that, for example, loading is not true at the same time error is true, or like we have data while we're still loading, or just basically there's many possible states that can happen here, and we might end up with some impossible state. So how do we manage that? Well, the first step, we could use a string enum. So instead of is loading, is success, etc., we could have that over here. And that doesn't really solve the problem, though, of that type safety that we really need. And so that's why I think that using discriminated unions is actually really helpful, because we could narrow down what the state of our shape, or what the shape of our state can be based on that status value. So for example, if it's success, we know that data is defined. If it's error, we know that we have an error string. And if it's loading, we know that we don't have any data. So we're not going to have any type errors, and we can guarantee the types and the shape of our states just by that discriminated union. And check it out, we've actually eliminated a lot of useState here. So we really only need to set one thing. And again, this is completely type safe. So you're going to have autocompletes. You're going to ensure that the result is exactly what you expect. So that's discriminated unions. Another way we could get rid of states, while I have only 8 minutes left, is getting rid of derived states. So I feel like there's two main types of states. There's primary states, which is like primary from the source, and there's derived states, which is derived from that primary state. So in this example, we have total item, subtotal, etc. And whenever those items change, then we're recalculating all of those in a use effect, which is my second favorite hook. So instead of doing that, we can eliminate the use effect and honestly just compute derived states directly in render. And I know we're talking about donuts over here. I know croissants are a big thing in Paris. This is a cronuts, by the way. I don't know if that's illegal here, but they're really, really delicious. So sorry for all the donut references. But yeah, I'm going to breeze through this a little bit as I'm short on time. But now we're going to talk about reducing logic. I wouldn't say states, but more logic. I know what you're thinking. Not this. I know you're thinking, I hate useState. Or maybe that's just me. And you might be thinking I'm going to come to you and say, hey, there's this thing called useReducer. Right? Yeah, so it's true. No one likes useReducer, but it can honestly be very useful in certain situations. In fact, like even the simplest situation like this, where we have a simple toggle, like nothing gets simpler than this. We have a toggle. Instead of doing useState, the opposite of whatever the value is, like not is active or is active equals true, then set to false, whatever, just use a reducer, and then that's all you have to do. And you could just use toggle, and it will just change the value according to that. But where useReducer really shines is when you have more complex state logic, and you need to really constrain that logic so you can't just update state from anywhere. So for example, if we have we have a donut shop, and we're adding and removing donuts, instead we can combine that logic into a donut reducer. And the reason I'm doing it here is because in this donut logic, we're actually having to check the inventory. So going back here, we have to check the inventory to make sure that we can actually add those donuts. So we have that extra safety, and we have those constraints to make sure that our logic and our state actually ends up being correct. And another great thing about using a reducer, just the general concept of it, is that it can be individually tested, and it is portable. So really, when your logic gets more complex, consider useReducer, but it's one of those things where you'll know when you need it. I'm not encouraging you to just use reducer everywhere, but just where it helps. And so I would call useReducer indirect state management, because you're not directly updating state. You're using events, or as the React team calls it, actions, in order to indirectly update that state, which allows you to actually express events which cause that state change, which give you a lot of benefits. Events contain information that direct state updates don't. They contain causality, the context, like what caused a state change and why. You can even add timing information to it, or you could collect events and have traceability. So very, very useful, and that's why I think that having indirect state management with all those constraints makes your state management a lot more simple. So in general, use Reducer for complex UI logic and state updates where your pieces of state actually have to depend on each other. All right, so I'm gonna breeze through this, but we have hydration mismatches too. Let's say that you want to just show the dates. This isn't gonna work in your client's component because how dare you try to just show a date in your component. So you might have to use effect and say like, okay, when we're on the server, show null, otherwise set date. But this won't actually work either. You can use sync external store to actually show a client snapshot versus a server snapshot, and ignoring those errors. The right way to do this would be to basically have it as a string, and so that string gets passed from the server to the client, and then you can just show the client's value versus the server value, and really you don't need useState for that either. This actually comes from a really great article by Dominic called Avoiding Hydration Mismatches with Usync External Store. And I mentioned that just to quickly talk about external stores, because really external stores are that missing piece between having global state with actual logic and having local state. Because React doesn't really have a built-in solution for wanting to share states between different components. So that's where useSync external store really comes in. And if you don't know about this hook, I would excuse you because it is hidden in the other hooks section. And so they give an example on the React documentation with the to-dos app, where basically you just pass in a way to subscribe to the store, a way to get a snapshot and from the client and from the server, and then you can connect to that store. So I'm going to breeze through here a little bit. However, the React team does still suggest that you use state and you use Reducer, because useSync external store, it's really for third-party libraries. It's not something that's really meant for you to directly integrate with. But if you're using browser APIs like checking the window width and things like that, it's extremely useful. So now, while I have 2 minutes left, I knew I had too many slides, I'm going to talk about third-party libraries. So what's the motivation for this? Let's say that you want counts and you basically want to constrain this, so eventually you get to use Reducer. I will share these slides, so sorry that I'm breezing through it 1 second at a time. But basically, we end up in a place where we end up reinventing Redux at the end of the day. That's basically what all those slides were showing. So there's two different strategies for this. There's basically having a direct store object that you could subscribe to and send events to, and that is imported directly into the components. This is what useStates does. Or you could basically pass that store via context, and that way you could isolate where that store goes, and it's actually very useful for testing. So lots of libraries do this, but I want to talk to you real quick about useState, not useState, but actually useState store. If you aren't familiar with this library, it's actually a much smaller version of useState, which allows you to very easily define stores. So you basically import create store from useState store, you provide the context, which is your state data, and you provide basically actions or ways that you transition the state. And then you could subscribe to state changes, and then you could trigger those events just like that. You pretty much know the entire API. If you want to learn more about useState store, then please talk to me after or during the break. But I think that it's really exciting because it makes state management very simple. It's basically like useStates, and hopefully you hate it less than use Reducer. Oh yeah, you could use stores in a local components too. So it could be a global store, it could be a local store, and also it handles effects as well. So we could have the ability to emit events, and then to subscribe to those and actually execute effects declaratively. So yeah, and this is something that I feel very strongly about. Effect management is part of state management. And this basically defines how your entire application works. Whenever an event happens, it changes the state, but it also produces effects. And this is known as a state transition. I think the translation in French is this. I'm not sure. But anyway, the last thing I really quickly want to talk about is local first state, where instead of just talking to APIs and HTTP and fetching data, you could essentially have a direct synchronization with your database. And so there's tools like Electric SQL and a bunch of other tools that allow you to essentially subscribe directly to your database and just show that real-time data. And so this is why I'm very excited for local first state. I think it's going to be the future. So in conclusion, I would say useState, I want you to truly use it for only component internal UI state as much as possible, and ask yourself, is there a better pattern? Because especially with React 19, there usually is. And so my general advice to you, start with useStates, and then refactor to better patterns as your application gets bigger, and focus on maintenance. Like, instead of saying like, oh yeah, this useStates update triggers this use effect, which calls these other useStates, and then this other use effect changes that state over there. Get rid of that. That's the easy approach, and focus on simplicity, where this event changes this state, and then it renders to the component, and you have a very easy mental model of thinking about your app, no matter how complex the state gets. So with that, thank you so much, React Paris.